Hi students, welcome to today's class. I hope that you are all writing examinations very well and preparing very well for your examinations. So all the best for your next tomorrow's examination. So today what I am going to do is I am explaining some very important models so these problems will help you to get a good marks in your tomorrow's JEE mains examinations. Okay now, so without wasting your valuable time, so let us start the class. See the first problem here. So let alpha be the roots of the equation x minus a into x minus b is equal to c, where c is not equal to 0. Then the roots of the equation x minus alpha into x minus beta plus c is equal to 0 are. So this is a very easy problem. So first of all, one equation is given, that is x minus a into x minus b is equal to c. So that is a x minus a into x minus b minus c is equal to 0. Okay now, it has two roots. What are the two roots? Alpha and beta. Therefore, we can write down the quadratic equation whose roots alpha and beta as x minus alpha, x minus beta is equal to 0. Am I right? The quadratic equation whose roots are alpha and beta is x minus alpha into x minus beta is equal to 0. That means these two equations are same. Both are same. That means x minus a into x minus b minus c is equal to x minus alpha into x minus beta. Okay now. Let us take minus c to right hand side. So therefore it will have x minus alpha into x minus beta plus c is equal to x minus a into x minus b. X minus alpha into x minus beta plus c is equal to x minus a into x minus b. What is the meaning of this? What is the meaning of this? This expression can be already x minus alpha, x minus beta plus c is equal to 0. Is equal to 0. That means this expression is factorized as x minus a and x minus b. Therefore, what are the roots of this equation? A and b. What are the roots of the equation? A and b. Therefore, option C is the correct answer. This is the logical way of solving the problems. Understand this? Very nice problem. So, this type of small problems are also giving in our JEE mains examinations. Okay. I hope that you understand this solution. So, let us go for next problem. Hi students, welcome to this problem. So, here see this problem. If modulus of f of x is less than or equal to mod x for all x belongs to real numbers, then f of x is continuous set. If modulus of f of x is less than or equal to mod x for all x belongs to R, then f of x is continuous at where? Which of the point it is continuous? At is equal to 1, it is equal to 0, x is equal to minus 1, let us see that. How to do this? Here one and only one information is given, that is modulus of f of x is less than or equal to mod x. This is a for all x belongs to real numbers. Okay now, right. For all x belongs to real numbers means let x is equal to 0. Let us see what happens. So that is equal to modulus of f of 0 is less than or equal to mod 0. This implies modulus of f of 0 is less than or equal to 0. That implies f of 0 is equal to 0. One of the case, that is modulus of f of s is less than or equal to 0 means, so this is possible only when f of 0 is equal to 0 only. Why? Because the modulus value never be negative. Never be negative. This is possible only when f of 0 is equal to 0. From that case we got. Right, let us see. Next condition is here modulus of f of x is less than or equal to f of x. We know that modulus of any number or any function is greater than or equal to 0. Okay, now it is either 0 or positive. That's why 0 less than or equal to modulus of f of x less than or equal to mod x. Okay now. Let us apply the, whenever such a type of inequality appears in between the functions. So immediately think of the sandwich theorem. Okay, na? So now I am going to apply the sandwich theorem. Okay, so let us apply the sandwich theorem as a limit extends to 0, 0 less than or equal to limit extends to 0 modulus of f of x less than or equal to limit extends to 0 mod x. So that means throughout the inequality I applied limit extends to 0. So this is clearly it is a 0 less than or equal to limit extends to 0 modulus of f of x. We know that modulus of limit extends to 0 f of x less than or equal to 0 extends to 0 modulus of x is equal to 0. Okay, now right. So let us see this. So actually limit extends to 0 mod x. So this is equal to, it does not exist. Limit extends to 0 mod x value is equal to how much? Limit extends to 0 mod x value. If x is less than 0, if x is less than 0, so if x has the mod x is equal to minus x. So therefore limit extends to 0, this is a minus x, therefore minus 0. Yes, it is it exists 0 minus x and plus x, in both the case you will get 0, you will get 0. So from this you will get this limit extends to 0 f of x is equal to 0. That means our limit extends to 0 f of x is equal to 0 means 0. You call it as 2 and you call it as 1. See here from 1 and 2 limit extends to 0 f of x is equal to limit extends to 0 f of x is equal to f of 0. Limit extends to 0 f of x is equal to f of 0 means what? F is continuous at x is equal to 0. F is continuous at x is equal to 0. Therefore, option B is the correct answer. Okay, na? Option B will be the correct answer. Okay, right. I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. So very easy problem. So one of the very good thought provoking problem this is. Find the number of positive integers from 1 to 1000 which are divisible by at least 2 or 3 or 5. At least 2 or 3 or 5. Okay, now that options are also given 735 or 736, 734, 738. Okay, now. So we have to find out the number of positive integers. Positive integers means what? Natural numbers. So these are set of natural numbers we have to find out from 1 to 1000 which are divisible by, the number should be divisible by at least 2 or 3 or 5. If it is divisible by all the 3 numbers, it is okay. It is divisible by 2 and 3, okay. If it is divisible by 3 and 5, okay. If it is divisible by 2 and 5, okay. If it is divisible by all the 3 numbers are also okay. Okay, now. But it should be divisible by, the number should be divisible by either 2 or 3 or 5. How many numbers are there? So that is the problem. Then how to proceed this problem? How to proceed the solution? Here from 1 to 1000, so there are 1000 numbers are there. We know that the number of, let A1 be the set, A1 be the set containing the numbers which are divisible by 2. Like that A2 also, A2 is a set, A2 is that means n of A1, n of A2, the number of elements in the set A2 which are divisible by 3. N of A3 means the number of elements, number of numbers from 1 to 1000 which are divisible by 5. Okay, now in the set notation, you want n of at least 2 or 3 or 5 means what? You have to find out n of A1 union A2 union A3, that you have to find out. N of A1 union A2 union A3 you have to find out. This is given by the formula by addition rule, extension formula, n of A1 plus n of A2 plus n of A3 minus n of A1 intersection A2. Okay now, minus, otherwise we will do for our convenient, we can say like this. This is a A2 we can take, this is a A3 we can take. If you take A5, that will be very nice. That means A2 is a set containing the elements which are divisible by 2, A3. So this is a, you can take a 2 and it is a 3. If it is a 5, it will be nice. This is a 2, this is a 3 and this is a 5. This is a 2 and 3 minus n of A3 intersection A5 plus n of A2 intersection A3 intersection A5. So this formula we have to know. Now one by one we have to find out n of A2. N of A2 means what? The number of elements belongs to 1 to 1000 which are divisible by 2. This is given by A2. This is given by, we have very short trick formula, that is step function of 1000, total number of 1000 by 2. 1000 by 2 is equal to how much? 1000 by 2 is equal to 5. Step of 5 is equal to 500. N of A3. N of A3 means what? 1000 by 3. 1000 by 3 means how much? 333.3333 will come. So this is equal to 333. Okay now? Right. So this is over, this is over. Now n of A5. That means step function of by 5. So this is equal to 200. This is equal to 200. That means the number of numbers which are divisible by 2 between 1 and 1000 are 500. What are those? 2, 4, 6, 8. If you go on, half of the numbers will be divisible by 2. But divisible by 3 are 333. Divisible by 5 are 200. Now we have to find out n of A intersection A2 intersection A. That means the number of elements which are divisible by both 2 and 3. That means what? The number of numbers divisible by 2 and 3 means what? The numbers which are divisible by 2, 3 LCM 6. That means step of 1000 by 6 you have to write down. Okay now? So let us continue the solution. Welcome back to calculation. So here now we have to find out n of A2 intersection A3. That means the number of elements which are divisible by both 2 and 3 means it should be divisible by 6. That is equal to 1000, step of 1000 by 6. So if you divide 1000 with 6, so this is a 166 you will get. So if you want to check it, 6 ones are 6, 4, 40, 6 6 are 36, 40, 0, 6 6 are 36, 40, 0.6, 166.666 will come. Step means 166 we will take. Now n of A3 intersection A5. The number of elements which are divisible by 3 and 5 are nothing but the LCM of 3 and 5, 15. That is equal to 1000 by 15. Now step of 1000 by 15. Let us see 1000 by 15. So divide 1000 with 15. Understand? So divide 1000 with 15. So 15 6 are. This is a 90, 100, again 15 6 are 90. 10 will come 0.0 something, 66 you will get. 66 you will get. Okay. N of A2 intersection A5. This is a 1000 by 25. LCM of 25 is 10. So this is equal to 100. Understand? Now n of A2 intersection A3 intersection A5 is equal to step of 1000 by, what is the LCM of 2, 3, 5? 2 3s are 6, 6 5s are 30. Okay now, this 3 3 will cancel, 100 by 3, 100 by 3 means 33.33 something, 33 you will get. So total final answer is equal to how much? So n of A2 plus n of A3 plus n of A5, that is equal to 500 plus 333 plus 200 minus n of A2 intersection ET, that is a 166 minus 66 minus 100 plus 33. Okay now. So if you calculate, so this is equal to 734. So these are 734. Understand? Right. From this, sometimes the question may be asked like this. Find the number of positive integers from 1 to 1000 which are not divisible by, at least 2 or 3 or 5. Not divisible by at least 2 or 3 or 5 means, then what is the answer then? 1000 minus 734. Whatever may be the answer. 1000 minus 734. Those are the numbers which are not divisible by at least 2 or 3 or 5. So not divisible means what? First you find out the number of integers which are divisible by either 2 or 3 or 4, 5, just like same procedure. From 1000 you subtract this 734, whatever may be the answer you will get, that will be the final answer. Okay now? Right, I hope that you understand this solution. So let us move to next problem. Hi students, welcome to this problem. See here, this is a problem from sequence and series, particularly progressions. If sigma r runs from 1 to n, tr is equal to n times 2n square plus 9n plus 13, then find the sum sigma r runs from 1 to n square root of tr. That means here square root of tr. Don't think that if you put square root of tr, therefore we can put here also square root of tr. So that property is not there. So once again, so sigma r runs from 1 to tr is given. We have to find out sigma r runs from 1 to n root of tr. Understand? So let us take this solution. Okay, right. First, sigma r runs from n tr means what? Sum to n terms. This is that means what? T1 plus T2 plus T3 plus so on Cn. That is r runs from 1 to n tr. N into 2n square plus 9n plus 30. Okay now? Now what is, let us find out what is SR. SR is nothing but SR minus TR is nothing but SR minus SR R minus 1. This formula we have. So what is the formula? Is generally Tn. We write down Tn is equal to Sn minus Sn minus 1. If we want to find out nth term, if you subtract from sum to n terms minus sum to n minus 1 terms. So TR is equal to SR minus SR minus 1. Okay now. So this means Sn is this. SR means substitute R. That means R into 2R square plus 9R plus 13. This is SR minus SR minus 1. SR minus 1. Wherever n is there, R minus 1 you substitute here. R minus 1, 2 into R minus 1 whole square plus 9 into R minus 1 plus 13. Okay, right. R 2R square plus 9R plus 13 minus SR means wherever n is there, substitute R minus 1. Now, you have to simplify this expression. Okay now. Now, what shall we do? So, you have to multiply. So, no option. This is a 2R cube plus 9R square plus 13R minus, this is a R minus 1 into, so this is a 2R square, 2R square. Here minus 2R minus 4 plus 1 plus 2 plus 9R minus 9 plus 30. Okay now? Right. Let us simplify one more thing. Once again, this is a 9R square plus 13R minus so once again I will up to write down 2R square minus 4R plus 9R plus 5R. So this is a 5R, 2 plus 13, 15. 15 minus 9 means, so 15 minus 9 means 6 plus 6. Okay now? Right. Plus 6. Next one, you multiply this 2R cube plus 9R square plus 13R. So minus of, so this is equal to 2r cube plus 5r square plus 6r minus 2r square minus 5r minus 6. Okay. Let us open the brackets. Directly I am writing here 2r cube minus 2r cube will cancel. So this is a 5r square minus 2r square, that is equal to 3r square. 9r square minus 3r square means 6r square. Next one. So here 6r minus 5r, only r. 13r minus r, 12r. So this is 12r. Coming to constant, these 2r will get cancelled. Minus of minus plus 6 is there. Okay, if you take a 6 common outside, so this is r square plus 2r plus 1. This is a 6 into r plus 1 whole square. So on the whole, what you got? TR is equal to 6 into r plus 1 whole square. Then we will write it the square root. So square root of TR. Square root of, we will write out and we will continue the problem solution. Okay. So let us continue the solution. Welcome back to the remaining calculation. So this is equal to root of TR is equal to root 6 into r plus 1. Square root of r plus 1 whole square is equal to r plus 1. Now we want this sigma. So this is equal to sigma r runs to 1, TR is equal to root 6 into sigma r runs from 1 to n r plus 1. Okay, now r runs plus 1. Right, from this we can easily tell. So this is a sigma root 6 into sigma r means what? 1 plus 2 plus 3 plus so on n. Sum to n terms formula n into n plus 1 by 2 plus sigma 1 means 1 plus 1 plus 1. How many ones are there? n ones are there. So therefore this is a n. So almost the simplification is over. So this is equal to root 6 into, this is a n square plus n into 1 n plus 2n. So this is equal to 3n by 2. Otherwise this is a root 6 by 4. 6 by 4, root of 6 by 4. This is a 3 by 2. n square plus 3n. So this is your answer. So root of TR is equal to root of 3 by 2 into n square plus 3n. Okay. So such a this type of problems may be asked in the examinations. Okay. I hope that you understand this solution. Let us go to next problem. Hi students, welcome to this problem. So here the value of integral of 1 minus x sin x by x into 1 minus x cube into e to the power of 3 cos x dx. What is the integral of this function? Then how to proceed this problem? Let us observe here up to here. So that is equal to integral of 1 minus x sin x by x into 1 minus x cube e cube, and that means we can write down x into e power cos x whole cube dx. X into e power cos x whole cube. Can I write down? Yes, we can write down. Now here we will do a substitution type of problem. So here put x into e power cos x is equal to some t. Now take the differential with respect to x on both sides. That means x into e power cos x derivative e power cos x derivative minus sin x plus e power cos x into x derivative is equal to how much? 1 dx is equal to dt. Okay, now right. Here anything can be taken common outside. As we can take e power x taken common outside. So therefore e power cos x, if you take e power cos x, this is a 1 minus x sin x. X sin x dx is equal to dt. So therefore e power cos x into 1 minus x sin x dx is equal to dt. Okay, now right. So here x is 1 minus x sin x dx is equal to dt. So if you observe here, so this is equal to, but in place of 1 minus x sin x, 1 minus x sin x dx dt, we can write down dt. So what about e power cos x? E power cos x we can write down t by x. If you write down e power cos x, we can write it as a, here 1 by x is also there. So here by x you write down, here by x. If you write down, you have to multiply with the x here. So check once again, I am telling 1 minus x sin x dx, that means here 1 minus x sin x dx is equal to, we can write it as a dt. Of course, up to here 1 by e power. So this is equal to 1 by this e power cos x is equal to how much? This is a t by x. T by x. E power cos x is equal to t by x dx is equal to dt. From this you see here 1 minus x sin x dx by x, that is equal to 1 minus x sin x by x dx is equal to dt by t. So 1 minus x sin x by x dx is equal to dt by t. So your problem, our problem is equal to I is equal to, so I is equal to integral of 1 minus x sin x by x dx is equal to dt by t, that is equal to 1 by t into 1 minus, this is already t, we have substituted t cube dt. So now the total problem will become in t. In this case, what you have to do now, let us take a t cube common outside. Let us take t cube common outside. This is a 1 by t to the power of 4, 1 by t cube minus 1 dt. Okay now? Okay now? Right. T to the power of, if you take an t cube common outside, already t is outside, t to the power of 4, 1 by t cube minus 1. Here we will go another substitution. What is the substitution is? Put 1 by t cube is equal to y, some y or k. 1 by t cube is equal to y. So what is this integral? So this is equal to t power minus 3. So what is the, if you take a derivative, so what is this t power minus 3? Minus 3 into t power minus 4, minus 3 by t power 4 dt is equal to dy. Okay now. That means 1 by t power 4 dt is equal to minus 1 by 3 dy. So 1 by t to the power of 4 dt is equal to minus 1 by 3 dy. Okay now? We will substitute there, we will continue the calculation. Let us continue the solution. See here 1 by t to the power of 4 dt is equal to minus, so this is a minus 1 by 3, 1 by t cube minus 1. 1 by t cube minus 1 we have taken as, so this is a 1 by t cube minus 1, total you take y, no problem. 1 by t cube minus 1 you take y, substitution y, because unnecessarily again minus 1 will come. So then only you will get the same. So this is equal to y dy. Understand? So this is equal to minus 1 by 3 log of modulus of y plus c. From this, the integral part is over. Now it's resubstitution, all resubstitution. We are going back to the original problem. So our problem should be in terms of x. So that's why resubstituting 1 by 3 log of modulus of. What is your y? Y is nothing but 1 by t cube minus 1 plus c. 1 by t cube minus 1 plus c. What is your y? Y is nothing but 1 by t cube minus 1 plus c. Again minus 1 by 3 into log of 1 by. What is our t? What is our t? X into e power x. X into e power cos x whole cube minus 1 plus c. Understand? So this will be the final answer. Otherwise you can write down x cube into e power 3 cos x. X cube into e power 3 cos x. That will be the final answer. Okay, now in the options this will be there. You put the answer. Okay, right. I hope that you enjoyed today's class. With some more problems, those who are writing for seriously for examinations, different models, I will stand before you. So until then, all the best.